All right, so today we're going to start talking about statistics. Just a little bit of review, recap of concepts you should already know. The mean and the median are both called measures of central tendency. It helps us to center the data. The mean specifically is the statistical average of the numbers, and the median is the 50th percentile of the data. And I have that written down here. The mean is the average, whereas the median is the 50th percentile. What that means is that the median is that number in the middle where if half of the data, or 50% of the data, is lower than that number, and the other 50% of the data is higher than that number. So the median is exactly in the middle when the data is in order, and the mean is actually the average. We have a special notation for mean, or symbol for mean, and we call it X bar, and that is the symbol that you're going to see as we go through the statistics for mean. Median doesn't have a special data, or a special symbol. Up here, what you can see is the quartiles, and quartiles is exactly what it sounds like. If we split the data into fourths or quarters, we would have a 25th percentile. The 50th percentile is specifically called the median. The 75th percentile is at the upper third, or quarter, and then the interquartile range is actually the difference from the third quartile minus the first quartile, and you actually take the subtraction. The range is highest minus lowest, and again, you actually physically take the subtraction. And these are all what we call measures of dispersion, or how spread out the data is. It's also called the variability of the data. Another thing that you should be bringing with you from other courses is how to work with data that comes in a frequency table and what that means. Okay, so here's a set of data. There are 13 pieces of data, and I'm going to find the quartiles. So the first thing you need to do, I think the easiest thing to do in this case, because it's displayed, is to find what we would call the median, which is the 50th percentile, and that's the piece of data in the middle. So because there's 13 pieces of data, half of 13, of course, is 6.5. And so if I go in 6 pieces of data, my median is going to end up being right here at number 7. There will be 6 pieces to the left and 6 pieces to the right. So this right here is what I would call my median, or my 50th percentile. Once I have that placed, then I'm going to take the data to the left of that median, and I'm going to find midway between these 3, or these 6. And so halfway between those, of course, is right here between 3 and 4. So there will be 3 pieces of data in the first quartile and 3 pieces of data in the second quartile. This would fall at 3.5. And then I would do the same thing for the upper half of the data. I would find where we split it in half. This would be the quartile 3. Whoops. This would be quartile 3. And if I take the average between 11 and 14, I will find that I am at 12.5. So if I wanted the interquartile range, for the interquartile range, I would actually take the 12.5 and I would subtract the 3.5, and I could tell you that the interquartile range is actually 9. And they call that the IQR, for interquartile range. So here's an example that we can use just to kind of refresh our memory on some of these concepts. We have marketers that are studying the ages of teenagers using social networking sites. They survey 100 teens for a particular site and find an age distribution given in the table below. That means the different ages of the teens that they surveyed. Part A says find the mean age of the teens using this site. Part B says 75% of all data fall at or below what age? So they're asking us for the third quartile. And C is what is the modal age of this data set, which means which one occurs the most. So what frequency is about is how often that age occurs out of the 100 teens that were surveyed. So 5 of those teens were 13 years old, 11 of them were 14, 17 of them were 15, etc., etc., etc. In order to find the mean age or the average age, I do not want to have to type these numbers in, all 100 of these ages in. I could type 13 in 5 times, 13 plus 13 plus 13, and then 14 in 11 times, and 15 in 17 times, and then divide by 100, and that would certainly find my mean. However, I'm not going to get any of the other information that I need from that one process that I'm going to do. So what I need you to do is get this particular problem copied into your notebooks with the table, and then tomorrow in class I am going to show you how to put this information into your calculator so that we can then calculate the mean and the quartiles and all the other information and how we're going to use it in the future. So your only task, so go ahead and stop the video and get this problem copied into your notebooks, and then tomorrow, like I said, we will look at how to put it in the calculator. Make sure you leave yourself a little bit of space then before the next piece in the notes so that you have some room to actually write. So a question like this we can do now because this one's pretty simple, and I just want to show you what this would be like. It says the mean and the median of the following ascending data set is the same or are the same. Find the value of K. Show your work. So K is a missing piece of data, and by the mean and the median being the same, because there are 8 pieces of data, the median would actually be the average of the 2 middle pieces. It will be at the 50th percentile, and because there's an even number of pieces of data, I would have to take the average of 7 and 8, the 2 middle pieces, and I would tell you then that the median is at 7.5. So if the mean and the median are the same, then the mean has to also be at 7.5. Now, the way you find the mean is you add them all up and divide by how many there are, which means if I take the sum of 2 plus 4 plus 6 plus 7 plus 8 plus 9 plus 11 plus K and divide by 8 numbers, I should get 7.5. So the first thing I would do is multiply both sides by 8. So I'd multiply this side by 8, and I would multiply my 7.5 times 8, and I will get 60 on the left, 7.5 times 8. And on the right, I'm going to add up all of these numbers that I know, and that will give me a sum of 47, plus the K, the missing piece. And if that sum has to be 60, when I subtract 47 from 60, I can determine that K will be equal to 13. And so that is the missing value of K. So again, the mean and the median. The mean is the average. The median is that middle piece of data. So here I have, say, 11 test grades. Okay? We want to talk about outliers and the effect that outliers have on the data. And an outlier is a piece of data that falls way outside the rest of the data. It doesn't seem to fit. Okay? So here's my 11 test scores. They seem fairly decent, and if I took the mean or the average of these, I would actually get an average or an X bar, which again, remember this is the mean, equal to 87.9 to the nearest tenth. And of course the median would be equal to the middle value, and because there's 11 of them, 3, 4, 5, I would take this one here. The median would be equal to 88. They're fairly close to each other, 87.9 and 88. Ideally, if this was normally distributed data, and we'll be talking about that in the future, those would be the exact same number, but this data is pretty close. Now, let's say I take the same set of data, only I'm going to pull out this 82 here, and I'm going to replace it with a 42. So we had a really bad day. I would consider 42 to be an outlier. It is not consistent with the rest of the data. What I want you to look at, though, is how it affects both the mean and the median. Okay, because if I take the average now if I take my average, my x bar will actually be equal to 84.3 to the nearest tenth. You can see that my average has dropped, because of this drastic number here. However, my median is going to stay the same because the median is still the middle piece of data, and it will still be 88. As long as there's 5 pieces of data on each side, we're good. So you can see that the outliers on the data affect the average, but they're not going to have as big of an effect on the median or that middle piece of data. So the only other thing that I want to talk about in this video is the idea of a sample versus a population and what we're talking about there. When we're collecting data, say I want to do a survey. Let's say I want to determine if women or men, whatever, but let's talk about women right now, age 20, age 30, age 40, age 50, and age 60. And let's say we want to determine the proportion of women at each of those ages that, I don't know, say belong to a gym and work out regularly at a gym. So if that's the question that I'm posing, it wouldn't be practical for me to ask every single woman age 20 and age 30 and age 40 and age 50, etc., whether or not they belong to a gym. That would be my population. So unless I can go out and find every single 30-year-old woman and ask her, do you belong to a gym and do you work out regularly? You have to consider the practicality of that. So what we do is we actually use what's called a sample. And so the sample needs to represent the population that I am curious about. So I would need to make sure that I get a good sample of 20-year-old women and 30-year-old women and 40-year-old women. Gathering your sample is a whole nother ball game because you need to make sure that it's random. You need to make sure that it represents your entire population. So and again, if you're more interested in that, take AP Statistics because we talk about that. So the sample versus the population, I might go out and sample 100 20-year-old women or 1,000 20-year-old women even. And then I would make a prediction about the whole population based on the results that I got in my sample. What you need to be careful of here is that when you're looking at a sample versus a population, the population deviation, which is how different the data is from the mean, standard deviation, is represented by this, sigma sub x. So it's the sigma of the sample x. When we're using a sample, the standard deviation is represented by s sub x. So this Greek sigma, Greek s, is for the population, which is if you could ask every single person aged 40, or female age 40, whereas the sample deviation is only for those people that you actually asked. That is actually representing the population. It is important to pay close attention when you're doing a problem as to whether or not you're using a sample or whether or not you're using the entire population. I will tell you that most of the time at this level, we use the entire population. You'll talk about, even say, Mrs. Feasley's looking to find the average of the average score on the last test for her math students. I would use every single one of my math students and their results in order to find the average. I wouldn't leave anybody out. I wouldn't need to take a sample because when you only have 80 students taking a course, it's very easy for me to do that. Okay? Okay, so hopefully you've had a chance to get all the notes down. We're going to talk a little bit more about how to gather, how to collect data. There's a little bit more terminology that we need to use, preliminary stuff. We'll be talking about that in class tomorrow. So hopefully you got all these notes down, and we'll see you in the morning or in the afternoon.